Hello everyone. In this lecture, let us learn how to solve a non-homogeneous linear recurrence relation with constant coefficients. So here you can see one example of it on board. It is the general form of a non-homogeneous linear recurrence relation with constant coefficients. So now uh, we will discuss the solution of it when f of n is of this form, s power n. Okay. So for that, let me take an example. With that, I will explain. An equal to 7 an minus 1 minus 12 into an minus 2 plus 2 power n. Okay. So now if we rewrite this equation, an minus 7 an minus 1 plus 12 an minus 2 equal to 2 power n. Now you can see that this is clearly a linear recurrence relation, a non-homogeneous linear recurrence relation with constant coefficients. Now its general solution will be of this form. An equal to, it will contain two parts. One part is the solution of the corresponding homogeneous recurrence relation plus one particular solution. Okay. This an of h is nothing but this an of h, that is a solution of an minus 7 an minus 1 plus 12 into an minus 2 equal to 0. So we solve this equation. If you want details, you can look at the previous lecture, right? So what is the solution here? That an of h is given by c1 into 3 power n plus c2 into 4 power n. This is the solution. Now it is enough to find this particular solution. Okay, it means when you substitute this into this equation, it must give us an identity. Okay, now what is that a and p? We need to find it. All right. So on the right hand side, we have 2 power n, right? So first of all, we need to verify whether this 2 power n is it a solution of the corresponding homogeneous equation. Let's see what is the solution of the homogeneous equation, which is here. One is 3 power n, other one is 4 power n. Okay, none of them are equal to 2. All right, so therefore no issue. Now we are going to take a n p, the particular solution, equal to a constant into 2 power n. Let me take that constant as p. So p into 2 power n. Okay, this is our guess, and we need to find this p so that it satisfies the given non-homogeneous equation. Okay, so for that what we have to do is we will find what is an minus 1 of this, which is p into 2 power n minus 1, and an minus 2, that is p into 2 power n minus 2. Now you substitute these guys in the given recurrence relation. What is it? That is an minus 7 an minus 1 plus 12 an equal to 2 power n, n minus 2. Now by substituting these guys here, that is p into 2 power n minus 7 into p into 2 power n minus 1 plus 12p to 2 power n minus 2 equal to 2 power n. Our aim is to find the p. Okay, so here you can take 2 power n common and also p. So by taking this out, we have 1 minus 7p came out, and here you'll have, this can be written as 2 power n into 2 power minus 1, that is nothing but by 2, plus 12, here you'll have 2 power minus 2, that is 1 by 2 square, which is nothing but 4. So equal to 2 power n. Now by comparing right hand side and left hand side, you can easily say that this p into this expression is equal to 1. Okay. Now what is this expression if you simplify? This is actually 1 minus. So you'll get 2 by 4 and that will be equal to 1 by 2. Alright. So this implies we get P by 2 is equal to 1. This implies what is P? P is equal to 2. So therefore, the conclusion is that the particular solution for the non-homogeneous equation is 2 into 2 power n. It can be rewritten like this, that is 2 power n plus 1. So this is the particular solution. Okay. Now you can simply do one thing. You substitute this in a given equation, you must get an identity. Okay. You can verify that. Substitute this one here and you will get an identity. It means that is a particular solution of this equation. Now let us see what is the general solution here. Now all possible solutions are given by that is an of h plus an of p. Homogeneous solution plus the particular solution. So therefore an equal to what? C1 into 3 power n plus C2 into 4 power n plus we got this one as 2 power n plus 1. So this is the solution. Okay. For all n, it depends on from where it is given. Let me take n greater than or equal to 0. Okay. So this is how we can easily solve a non-homogeneous equation. Remember, here f of n is 2 power n and this 2 power n is not a solution of homogeneous equation. Now let us think about the case if this f of n is a solution of the corresponding homogeneous equation. For example, instead of taking 2 power n in the previous problem, I would like to take 3 power n. Alright. So let me take this problem, that is an equal to 7 an minus 1 minus 12 an minus 2 plus I am taking 3 power n. So earlier we have 2 power n, but now I am taking 3 power n. So why I have taken that? Because if you look at anh, which is C1 into 3 power n plus C2 into 4 power n. So this 3 power n is a solution of the corresponding homogeneous equation. So therefore, now what is a and p? So you are not allowed to take p into 3 power n. Okay, because when I substitute this, a constant into 3 power n in this expression becomes 0. That never be equal to 3 power n. Okay. So for that, what we have to do is, first you see how many times this 3 power n is a solution of this equation. I mean, we find the root of a characteristic equation, right? You see this 3, how many times it is root of that characteristic equation. It means you need to see the algebraic multiplicity of 3. Okay. If it is 1, here it is 1 anyway, then we take n power 1 into this as our case. Suppose if it is a root of multiplicity 2, then we will take n square into p into 3 power n. Suppose if it is a root of multiplicity 3, then we will take n cube into p into 3 power n. Okay. So anyway, here multiplicity is only 1. Therefore, it is enough to take the first expression. Alright. So no need of taking these guys now. Right. So now let me take an equal to, that is pn into 3 power n, right? And you can easily find what are an minus 1 and an minus 2, right? Now you substitute this entire expression in the given equation, that is an equal to 7 an minus 1 minus 12 an minus 2 plus 3 power n. So here let us substitute this. So first one is np into 3 power n equal to 7 into np into 3 power n minus 1, sorry, this will be n minus 1 into p into 3 power n minus 1 minus 12 n minus 2 p 3 power n minus 2. Okay. Now there is one more term plus 3 power n. Okay. Now like the earlier, you can take 3 power n outside. You bring these terms one side, right? Or okay, you keep it like that and you take common. So 3 power n, n into 3 power n into p, that equal to, on the other side what we have, 7n minus 7 into p, and here you can take 3 power n common, so that you will have divided by 3 minus 12 into n minus 2 into p, anyway we have taken out. Now 3 power n also you take it out, therefore you will get 3 square. Okay. So close it into 3 power n plus 3 power n. Okay. Now you bring this expression one side because it is having p common. So p into, I hope we can remove that 3 power n because every term is having it, right? So if I bring it one side, this is p into n minus, you'll have 7n minus 7 by 3. This becomes plus now. This is 12n minus 24. I hope we can cancel 3 and here. So if I cancel with 3, we will have 4. So this is 4n minus 8 divided by 3 equal to 1. Okay. Now we need to simplify this. So this implies p into, so you take LCM, LCM is 3 and you add the terms, you'll have 3n, n is getting cancelled, right? So because we will have 3n minus 7n plus 7 plus 4n minus 8 by 3 equal to 1. Okay. Now you can see that plus 3n plus 4n minus 7n cancel. So here 7 minus 8 by 8, that is minus 1 by 3. So therefore p into minus 1 by 3 equal to 1. So this implies what is p? So p is nothing but minus 3. All right. So now therefore, what is a and p, the particular solution? That is minus 3 into n into 3 power n, because n p into 3 power n, that is what we have taken, right? So you can finally write minus n into 3 power n plus 1. So this is the particular solution. Okay, let us verify. Let us verify whether we got it correct or not. Okay. So for that, what I have to do, I need to take the given expression, we need to substitute this expression here. Let me substitute. So here minus n into 3 power n plus 1, that equal to 7 into, see the problem is over here. Okay, I am just verifying. All right. So 7 into, this is minus of n minus 1, okay, into 3 power n minus 12 into what is it? Minus n into, sorry, minus of n minus 2 into 3 power, you will have n minus 1 plus 3 power n. Okay, so we need to simplify this expression. So this side we have minus n into 3 power n plus 1. Let's see what do we have it on the other side. I hope we can take 3 power n common from the entire expression. So by taking 3 power n common, we have minus 7n plus 7. And here we have minus into minus plus 12n. So here minus into minus plus, and again one more minus is there, therefore minus 24 into, so we have taken 3 power n common, right? So we will have by 3 plus 3 power n. Okay, so on both sides we must get the same expression. So minus n into 3 power n plus 1 equal to 3 power n into, let us try to simplify it. You take LCM. So if you take LCM, what do you get? Minus, you'll get 21n. I hope we can cancel 3 here. Right. So now finally, let me write it here. Minus n into 3 power n plus 1 equal to this side 3 power n into, we will have minus 3n, yeah, and 7 minus 8 minus 1, and you take 3 power n common plus 1. That's it. So this equal to 3 power n into minus 3n. This side we have minus n into 3 power n plus 1. So minus n 3 power n plus 1 equal to minus 3 into n 3 power minus n into 3 power n plus 1. So we got an identity. Therefore, this is the particular solution of the given non-homogeneous equation. See, uh, while writing answer, no need of writing this part, no need of verification. Okay, just for our satisfaction, I verified it. All right. Now, what is the final solution to this problem? So therefore, the final solution, that is an equal to an of h plus an of p, that equal to c1 into 3 power n plus c2 into 4 power n plus, I hope we got minus, okay, minus n into 3 power n plus 1. That's it. Okay. So I hope you understand how to solve a non-homogeneous linear recurrence relation when the right hand side function is either r power n. If r power n is a root, we will go this way. If it is not a root, we will go like the initial. Okay. So I hope it is clear to you. Thank you.